When I began designing this game, I had the goal of creating something like a side-scroller or platformer, but I needed a variation. I like the way 2D games play. Their linear path makes storytelling simple, and it allows me to create art quickly. I eventually came up with the idea of having the game take place on a spherical planet, so that the character would follow the arc of the ground instead of moving perpendicularly left or right. The challenge then became, how do I code this type of movement? After experimenting for a while, getting the gravity right, creating colliders, and assigning rigid bodies to the characters and the planet to maintain and manage contact between them, I came up with a simple solution. I could simply rotate the planet underneath a static character. Another solution might have been to rotate the player around an axis point located at the center of the planet, but rotating the planet itself instead of the player ended up being the best solution for my project. It made the logic very straightforward when I put in various layers of foregrounds and backgrounds that also needed to be rotated at different speeds so that I could create the illusion of 3 dimensions in this 2D world. I also wanted the game to have a y-axis, but I didn't want to go with the stereotypical platformer model that involves jumping from platform to platform. Since I had this nice big planet underneath the character that wasn't being used, I figured it would be neat to explore underground. The game turned into a sort of mining game where the player must explore hidden territory to accomplish goals. I really enjoyed watching the game evolve as I began experimenting with the world I had created. Most of what I had originally written out as a design was quickly replaced with the new cool mechanics I was discovering playing my prototype. It gave me wonderful insight into the design process and how to generate creative thinking. Traveling underground led me to solve another logic puzzle. If the planet continues to rotate at the same speed as the character approaches the center, it appears as if the character slows down when moving left or right. I looked at the equations circumference equals 2 pi r and speed equals distance over time. Since circumference is distance in this situation, I looked again at the equation for circumference and realized that as radius decreases, circumference, aka distance, also decreases proportionately. What this meant was that as the character approaches the center of the planet, the radius is essentially decreasing, causing a decrease in his apparent speed. All I had to do was compensate for this loss of speed to make sure the player's apparent speed was constant. The math was simple. If the player was half his way to the center, meaning the radius was half of its original value, the rotation speed had to be doubled. If he was 3/4 of his way towards the center, rotation had to be quadrupled. One of the mechanics that I have coded in is the framework for a rhythmic minigame. The player must press the action button at the correct time during a song to complete the game. This window of time, when the player must press the button, is cued by a visual animation and by the music. I have a script here that will implement this in one of 2 ways, based upon a randomly chosen song. If the song emphasizes beat 3, as in 1, 2, 3, 4, the window opens up right before and ends right after that beat has been played. If the song emphasizes beat 4, as in 1, 2, 3, 4, the same thing happens during that 4th beat. I have accomplished this by using coroutines and IE numerators that trigger at the beginnings and ends of windows. By changing the value of variables depending on what moment in time we are currently in, I can control whether or not the game knows if we are within this window. If we are not in the window and the player presses the action button too soon or too late, I set a variable to tell the script that the player has failed this particular round and to disqualify proceeding presses of the button. This prevents players from simply spamming the action button to guarantee they find the window. If the player does press the action button within the correct beat, I have set an animation to begin that shows the ship, in this case, performing the relevant action, and text appears that says, "Good job." If the player does nothing at all, the visual cues informing the player that they must take some sort of action will still play, but the ship will not perform its animation. In this case, we are mining a piece of ore. The other bit of code that I want to discuss is my radar system. I realized that I needed to give the player some sort of radar so that they could more easily navigate when traveling underground and locate hidden objectives. I based this system off of a hide-and-seek game I used to play as a child in the playground. One person would close their eyes while the rest of us would shout out cold, colder, warm, warmer, hot, and on fire. These clues would give the player a location of the object while his or her eyes were closed. For my game, I've used flashing colors to indicate the same principle. Green is warm, yellow is hot, and red is on fire. At this particular point in the story, the player is trying to locate bits of ore and gems. When they approach some, the radar will flash the appropriate color depending on their distance. This was relatively simple to code, or so I had thought. I just needed different radar animations to trigger when the player's radar colliders collided with ore colliders. I set up 3 ranges, small, medium, and big, that corresponded to the 3 colors, and I gave it a shot. What I realized was that things were getting dicey when there were multiple bits of ore within range. I needed the red radar to take precedence over the other colors if there was a close ore and a medium distance ore, both within range. Also, when the player successfully mined the closest ore, the radar's color needed to switch to match the distance of the next closest piece. The last criteria was that when a player traveled past multiple bits of ore within range, the radar system needed to stay active until the last piece of ore was out of range. The code I had initially written made the radar turn off prematurely if any ore had left range, even if there was still another piece left within range. This was because of the way I had set up on-trigger enter and on-trigger exit events in C#. I was able to amend this by having the script count how many ores were entering and exiting, a variable that got +1 anytime an ore entered within a particular range, and -1 whenever a piece left its range solved this problem. By solving dozens of problems like this particular one, I have found that the simplest solutions are often the best ones.